In this video, we are going to talk about how to fix user fatal message 8109. This message happens when you're trying to implement glue or permanent glue with MSC Nastran. Now, by the end of the video, this is what we expect. Number one, we are going to fix this issue. And number two, we are going to confirm the contact status. The contact status is going to tell us exactly where the contact is configured. So here in the red regions, you can see that these different nodes or these meshes are attached, and that's ultimately what we want. We want to fix this error, and we want to make sure that the correct elements are connected together. So let's go ahead and do this. Let's go ahead and close this window, and let me make a backup of this original database. So let's go ahead and start. Now, there is an element normal that I have to define. So an element normal for 2D is as follows. When you look at the 2D element, for the most part, when you're looking at a C quad 4, it's composed of 4 nodes. You use this order of the nodes to determine the orientation of the element. So let me go ahead and open Patron here. So here's the model that has the issue. Let me show you what an element normal looks like. So if you go to meshing, create, or action show element coordinate system, here let's go ahead and deselect the X and Y. We just want to know what the Z direction is. That's the element normal. Let me change the background here. And let's go ahead and select this element here and click apply. So you see this Z axis is pointing in this direction for that element. Now let me go ahead and select these other elements. So this element normal is determined by the order of the nodes here on the list. Basically, you use the right hand rule. You can imagine that if this is node 1 here, this is node 2, node 3, and node 4. So you use the right hand rule, and that would give you the normal. Now, if you want to reverse the element normal, you can just do it in reverse. Your node IDs would go in reverse. Now here I'm doing it manually. There are ways to automatically do this in Patron, so I'll show you how to do that later in this video. Now, when you look at the message, this is giving you an idea of where the problematic normals are. Now, this is effectively a needle in a haystack. It's going to be very difficult to find where exactly that problematic normal is. So what you would do is the following. Here, if we look at the contact bodies, I have contact body 1 here, contact body 2 is here, and contact body would be the top. Now, if you look at contact body 2, there's a lot happening here. You can imagine if we plot the normals, all the normals are pointing in all kinds of different directions. Now, that might be a problem for Nastran's contact algorithm. Now, this is what I recommend doing for this contact body. This top mesh is never going to contact none of these nodes in the interior. This top mesh is going to contact only these top elements of the contact body. So what I recommend doing first, modify the application region, deselect all the elements that are not going to be contacted. So let's go ahead and do that and remove that and click OK and apply. So now these elements here at the top, the contact algorithm is going to be watching those elements for contact. Anything here in the middle, it's not going to detect any contact. And that doesn't matter. We don't care about the elements in the middle. We just care about the elements at the top because that's where the contact body is. So if this is contact body 1, this is contact body 2, there would be a contact between these elements. And then here, if this was contact body 3 and this was contact body 2, there would be contact between these elements. So now that I've deselected these elements, let's go ahead and try and perform a normal modes analysis with this. Now, I recommend using normal modes first because it tells you which meshes are connected or not. So here I've selected normal modes, click OK and apply. And let's go ahead and see if we've resolved one of the errors. So I believe this is this directory. Let's go ahead and look. Okay, so I believe we fixed the first error. We're still not done yet. So you can see that there is a change in the element IDs here. You can see that the list of elements is different before and after. So we've helped alleviate the issue. Now, let me show you where the issue was exactly a moment ago. If you go to meshing, go to meshing, go to show, element coordinate system, select only the z-axis, and let's go ahead and select maybe these elements. Now it's a little subtle here, but let me reorient this and let you know what's going on here. So you can see these elements here. I think it might be worth opening paint. So if this is one face of elements and this is the second face, and then here in red would be the z or the normal, so I'll call this the positive z. Ideally, you would want the normals to be in, how do I say, in a consistent manner when it comes to contact. So here, if we go about this corner, ideally the positive z direction, the normal of the element would be in the same direction. So here are just some examples, but that's not what's happening here. What's happening is the normals are actually going in a inconsistent direction. So that would be in this direction that you see here. So the fact that you're not consistent, the fact that one moment your normals are in this direction, but as soon as you round the corner, the normals now flip to the other side. That's inconsistent. Nastran's contact algorithm doesn't like that. Now, what we went ahead and did, since these were the elements that were causing the issue, and then if you want, what you can do is you can just copy this. Here in the bottom right, you would type in element, and then the IDs, click apply, and you can see that here it's showing you, hey, these element normals here at this corner are inconsistent. So what we did initially, we removed these interior elements from the contact region or the deformable bodies. We know that this interior region, it's never going to be in contact, so we can just remove those elements from the deformable bodies. Now, this didn't fully solve the issue. We still have some areas where there are inconsistent element normals. Now here, what you can do is the following. You can just copy here on the right. Let's go ahead and copy those two element IDs and let's go ahead and paste them here. And so now it's telling me that here I have inconsistent normals. You can see one is pointing downward and the other one's pointing in the up direction. So I have to fix these element normals before I can go ahead and perform a permanent glue configuration here. So what you would do is the following. You would go to meshing, go to modify, go to element, and shell orientation. So here you can manually orient the normal, if you will. So first select a guiding element. So basically the normals are going to copy the guide element's normal. So we'll select this element here. Now it's important that the element that you want to modify, you want to make sure that the guiding element is right next to the selected element. So here, Let's go ahead and select this element. Here in the guide element input box, you select the elements 164,607. Now, what about our element list? Remember, select adjacent elements to that guide element and click apply and show the current direction. And here, I don't think I've done this properly. Let's try it again. So here in the element list here in the bottom right, we're just going to click apply. And here's the one thing I've been struggling with this tool. Sometimes it doesn't work reliably, so I have to make sure this is working. So let's try again. Okay, now it works. So here, what I did is I selected the guide element, and remember, this should be adjacent to the other elements. I set match to normal and set the element list to the elements you want to flip. So now, let's go ahead and do this for the other elements. Let's go ahead and select these elements. So first, I delete the old elements, and now I reselect new elements. And here, if I click on show current orientation, you see that there's a mismatch. These normals are pointing in the up direction where the original element is pointing in the down direction. That's a problem. Now, I'm still using this guiding element. Now, if I click apply, I do not expect this to work. So you see it still didn't work. That's because the guide element should be right next to these selected elements. So let me select this element since it's adjacent to these elements. So I've selected this element since it's adjacent to these elements on the left. And now if I click apply, it works. Now let's go ahead and do this for the other side. Now here, let's just go ahead and look at what the current direction length. So you see the normals are in the up. Now let me select a guiding element. And remember, the guiding element should be next to those selected elements. So I've selected this element as a guide element, click apply, and now all of these elements are going in the same direction, or rather the normal is. Now again, what this option is doing, it's basically flipping, it's reversing the order of the node numbers here on the C-quad 4 element entries. Now, what you can do at this point, you can go ahead and show the element normals for all these elements. So maybe that's what I'll do right now. And we only care about these bottom nodes for now because those are part of the contact body. So these normals are all going in the down direction, down, 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 and down. Now, you see that these normals, they're kind of, to some level, they're kind of inconsistent. But that's okay because these elements are not part of the deformable body. These elements are not going to be considered in the contact algorithm. We're only considering these elements here. Now you can see that there is an issue here. There's an element here where its up direction is, or its normal direction is in the up, and these element normals are in the down. So we have to flip that normal. So if we go to modify show orientation guiding element, we'll go ahead and fix that. So let's rotate this a little. Now first, let me select the elements to modify. So we'll go ahead and select these elements, and let's show the direction. You can see that some of them, all of them, are in the up. And now for the guide element, let's select one element that's adjacent to that. Now, sometimes when you try and pick an element, you're actually picking an element that's in the back. So here you can see that I'm picking, suppose I try to pick this element. If you look at the orange part, I'm selecting this element from a different part of the mesh. It's actually trying to select this element. The picking here is picking an object through the mesh, and it's not what we want. So I think if I change this actually, right, so here if I modify this, let's go back to that tool, show modify. So here you can see that I want to pick this element as an example, but if you're not careful, you see it's picking an element in the back. So let me see if I can replicate that. So this is an element in the back we don't want to pick elements in the back. We want to pick what's immediately visible and in front of us. So you can click this option, visible entities only. So this will let you pick what's immediately visible to you. So here we'll select this element. And for the elements we want to modify, let's go ahead and select these elements and click apply. Now if you show the element orientation, now this is what I mean about this tool. Sometimes it works, sometimes it doesn't work. So here you can see it's flipped some of the elements, but not all of them. So here, let's go ahead and continue this. Okay, let me see what's going on. So you can see some of the elements were properly flipped, but the other elements weren't. So that's the odd thing about this tool. I'm not clear on why it's working sometimes and other times it's not. So let's go ahead and select these elements, try it again. Okay, so that looks a little better. Let's go ahead and do this. Let's go ahead and show the element normal and see if we've done this correctly. Oh, and since I've picked this option, visible entities only, it's not picking all the elements in the back. You can see it's only picking elements that are in the front. So you see it's only done this for elements that are in front of us. If you want to pick elements that are in the back, just deselect this option, visible entities only, and then you can pick the elements in the back. So let's go ahead and pick the elements in the back and click apply. And let's see if we can find a better angle for this. Okay, let's go ahead and reset the graphics and let's just pick these elements. And then let's see if I can use this to okay, perfect. So now if we look at all these element normals, they're all going in the same direction, which is what we wanted. So hopefully this would have gone and fixed the error that we had. So let's go ahead and now go to analysis and try to rerun this. And let's go ahead and look and see if there are any errors in this. Okay, so you can see that the error is now gone and we can see some results. This happens to be a normal modes analysis, so it's calculated the natural frequencies. And one of the reasons I like to do a normal modes analysis is the following. Let's go ahead and import the results and look at a French plot. And here we'll click the static subcase and turn on the contact status. The contact status lets you see what's connected. Here you can see that even though we have gaps in the mesh, the contact status is telling me where the contact region is. Now, you could do this in a number of ways. You can just use a French plot. Sometimes I like to use a marker plot. So here is change the object to marker and the method to scalar. And we'll select contact status and let's go to the third tab. So right now I'm in tab 1. And this is tab 2 and this is tab 3. Here you can select a different marker, click apply, and now you get circles. And then turn off this checkbox, show scalar label, and click apply. And let me see, let's go ahead and refresh this actually. So here at the top left, the broomstick, it turns everything off. Click apply again. And now I don't have those white labels. And now let's reduce the size of these markers. So instead of 0.1, let's try 0.01. And it's too small. Let's try 0.05. Okay. So then this is an alternative way of seeing which nodes are coming into contact with each other. So there you have it. That's how you fix that issue. Originally, there were normals in the middle of the contact body that were problematic. So here in the middle, there were normals that were inconsistent here in the middle. we removed these elements from the contact body, but then we still had another problem. The normals of these elements here at the bottom were not in the same direction, so we manually flipped them as we went through this exercise. And now, after we corrected all these issues, we then performed the normal modes analysis, and then we were able to see not only what the mode shapes look like. So let's go and look at the mode shapes. We were able to look at the contact status. So here's what this mode shape looks like. Sometimes I like to animate it. Let's go ahead and slow this down a little. So you can see that the meshes have a mode shape that's consistent. They're not technically moving together, but if you wanted to think of a mode shape as movement, then yeah, they're moving together. Now, watch what happens when I purposely forget to add a contact pair here. So let's suppose I did not attach. Here, first let me go ahead and turn on. So let's go ahead and remove 2 and 3. So 2 and 3, this is contact body 3 and this is contact body 2. I'm going to ignore contact pair 2, 3. So it's going to remove it and click apply, and let's rerun this. When you perform a normal modes analysis, any meshes that are not attached to each other, they are going to look like they're floating in space. So if you go to results and look at a mode shape, and let's animate this, you can see that this mesh is obviously not attached to the rest of the structure, if you will. Now remember, that's because I purposely left out that contact pair. The contact status we saw a moment ago is a way to determine what's connected. Also, looking at the mode shapes is another way to detect meshes that are not connected. If you look at the natural frequencies, any natural frequency that's close to 0, so here the natural frequency is 1 times 10 to the negative 5 hertz. Any natural frequency that's close to 0, that mesh is not satisfying your equilibrium equations. So if we look at those, so sigma symbol. So what I mean by the equilibrium equations, so some of the forces in the x should be 0, the y. So if you want equilibrium, you want enough supports to make sure that the sum of the forces in the x, y, and z, the sum of the moments about the x, y, and z, you want to make sure all of those are 0. Now, if they're not 0, let's see if I can get that simple, not equal. If they're not equal to 0, then you get what's called a rigid body mode. So rigid body mode means a deformation or motion without deformation. And then this gives you a 0 hertz natural frequency. And what this basically means is that the inverse of the stiffness matrix does not exist. So this is a very problematic issue that I see a lot of users get. That's why I always like using normal modes analysis. Here, if you look at the first 6 natural frequencies or mode shapes, they all have a 0 hertz natural frequency. And that's because this mesh, it's not constrained in any of the directions. There's no constraint along the x, the y, and the z. There's no constraint that prevents rotation. So normal modes is very simple to confirm whether or not the mesh is properly constrained. Okay, so I think that sums up the end of the video. Just as a quick conclusion, we had all these errors about the element normals being in different directions. We went through the process in Patron to fix the contact bodies and then fix the normals. And then after that, we looked at the contact status, and then we went over what a 0 hertz mode shape is. So that's the end of the video, and as always, thank you for watching.